speaker when they change laptop, as long as using the same port, it's okay, right? It won't affect. Okay. Because the speaker is late, so we didn't get a trial. Okay. Will they need to be mic'd up?
So because we're using this speaker, my cameras, microphone, so you catch whatever is in the background. Oh, this is Indian.
Actually, right? I was telling her maybe
I'm just also trying to make a joke. Why is it for? inside here.
They say if you provide water, then got no roofs.
Oh, yeah, true.
Almost 50%. Is the lighting camera here?
Yeah.
Oh, yeah.
No, I'm just using a coding screen right now.
Oh, it's okay, never mind. No, it's okay, it's okay. It's just being bored out. Everyone watching, I was thinking if it's like a moment where it's just we're just sitting here talking. Oh, okay. I share the link already. I share the link. I think number one should be okay. 63. Alright.
Alright. Still got 5 minutes, and then you get the people who are late for events.
Curious if the person I saw is it
Very warm.
Oh, sure. I would be very malu about that. Sure. Ah, I don't remember the name. Something like. Hey, oh shit. Just now it was 10 minutes ago already.
Hi everyone, we haven't started yet, but just want to gauge the room's interest very quickly. So later on, we have a breakout session for 2 tracks. Track 1 is infra and track 2 is data. So just want to get a clear sense of like what you are interested to be. Can I have a show of hands who's going for track 1? Okay, then for track 2?
Track 2 is data, right?
Track 2 is data, yes, track 1 is infra. Okay, thank you.
So I think
Start in the next 1 minute or so.
okay. Can.
So then it's fine. I can use it.
Hello everyone, thanks for joining us today in our first physical event for the last 2 years. I think it's been a really long time since we had an event like this. Really excited to have all of you guys over here. So yeah, my name is Wei Yuan, and over here at Parizwan, we are hosts and also the organizers of GDG Cloud Singapore for this event today. So how are you doing, Parizwan?
Hello. I'm doing okay, I guess. Like COVID has been like quite terrible in a sense. Like, you know, all the way stay at home. But I guess that's a good thing in a way. Stay at home, working from home is an enjoyable experience. Right now, like eventually now, I think some companies are out there like asking people to come back. Not looking forward to that too much. But yeah, I mean, I think things are that way. I suppose. Yeah.
Let's talk about something that's a bit of the elephant in the room. Also, I want to hear your secret here. So, since the start of the pandemic, we haven't really seen each other in a very long time. And you look very buff right now, to be honest. What's your secret?
Basically just monitoring weight. I mean, just sitting at home, not looking much. Yeah, nothing too major. Yeah.
Okay, so I guess enough of our chit chatter. I think most of our audience today will be anticipating our event today. So today's in-person event, right, is actually commemorating the season 5 of our Majulah GCP. So I think some of you might have already went through this. Hopefully for the last few times, if not the few seasons before, you can of course see like some of the swags that is over there conveniently placed in that picture. But also like this cap over here is one of the last few seasons swags. So later we'll go on to explain how you would qualify for these swags. Alright, so let's get to the event proper. So welcome to our event today. Thanks for taking this leap of faith in joining us in this physical event. But before we start, I'd just like to show a bit of gratitude for those people. There's a lot of back-end work being put in to make this day possible. I mean, a physical event in this COVID-19 landscape, in this pandemic. Definitely, there has been a lot of effort put in by many different parties over the last few weeks. Just to call out to them, to say their names. Of course, we have our volunteers from Engineers SG, Ever, the famous Michael. Some of you might really know him from events previously. And then we have Karen over here as well. And also a couple of our volunteers who's going to be, you will see them in the other room, again from Engineers SG, Robert and Hui Hang. And then today we also have our volunteers for GDG Cloud Singapore. So some of you would have seen them at the registration counter earlier on, as well as downstairs, right? Toru, JT, and Damien. And as well as our speakers who have kindly graced us, today to help us with conducting the study jams. So we have Johannes over there, as well as Vamsi over here. Yeah. And last but not least, our sponsor for this event, as well as the people who, they are the ones who got the venue for us, who got this program set up, who got the swags that you are anticipating for the end of the event later on, as well as for setting up Majulah GCP. So we have our Google DevRel staff, Fibra, who's not here today, but there's also Rachel, who was, I think she's here at the registration counter in the blue shirt, and also Janice over here. So I would like to ask for your help to join me in giving them a round of applause for setting up this event. Okay, so before we go into the main part of our study jam, I'd like to invite Janice to give a short welcome address to all of you guys.
Thanks to Yuan and Harrison. They're like the hostess of the mostest, and we were all talking about how we haven't actually run an event in 2 years and all a little bit nervous about meeting people and speaking in front of everyone again. But I can see Yuan and Harrison have no problem just jumping into it. Thanks again for joining us. Just a show of hands, how many of you are first-time participants of this Majulah GCP? Because in the last 2 years, we have had 4 online study jams, and you all have been so actively participating. Over 5,000 of you have joined us online. How many of you are first-time participants? Oh, this is really cool. So maybe about good 50% of the people here first time joining us. I'm glad to have you here. This event has been going on since actually the start of the pandemic, the hybrid study jam, and Wei Yuan and Harrison have been running 4 seasons of this study jam with over 5,000 participants. So it's good to see that there's still new people who are joining us and here today to actually learn in person. I'm very excited from the Google team. We have Rachel and we have Johannes and Vamsi, who is also here today. So if you have any questions, do feel free to use the resources that's in front of you and ask questions. We'll love to hear about your event experience and tell us, what you want to hear more of as well. All the community here is trying to do right now is maybe get a chance to meet you again and have a chance to get to work together with you to help you become more successful in your developer journey. So thanks again for joining us and being bright and early. Really excited to see everyone and hope to have a chance to meet all of you later. Back to you again.
Thanks, Janice, for the very wonderful welcome entrance. So let's go into our main program today. I think, from the audience just now, I can see some of you might not have joined Majulah GCP before. So I want to give you a little bit of a starter, understanding on what exactly is Majulah GCP. So, Harrison, what is Majulah GCP?
This is like quite a mouthful of a description, but essentially it's a self-study program. Previously, there was this platform called Quick Labs, where you go through and then basically you have access to an actual Google Cloud environment. Like this is not like a mock version, it's an actual Google Cloud environment. This Quick Labs platform, or now it's called Cloud Skills Boost, right? This Cloud Skills Boost platform will provide that Google Cloud platform environment for you to actually use the Google Cloud products. And alongside that, there will be a bunch of, let's say if you go through labs, all these labs or labs, right? There will be a whole bunch of instructions on how to do a certain topic. Like let's say you want to, if like on the infra side, like how do you set up to a VM in Google Cloud Compute, which is one of the products in the Google Cloud Platform Suite. How to configure it, how to use it, how to shut it down, and those kind of stuff. Alongside this Majulah GCP, of course, learning is hard. There's a lot of things that you might go wrong. You might maybe you write some code and like, okay, well, I don't know why this code is not working. So alongside it, we usually set up some kind of community that help out with this, help out the learning. So I think there's one platform that we're using called Slack. We have a Slack community group. So in case you have any issues, let's say you are blocked in a certain instruction and you don't know why, that instruction is no longer working for you, you can ping the Slack group and see if anybody else has the same problem. Maybe they can help resolve it as well.
So I think in addition to that, that's why we have physical events or online study jams like this as well, where we have speakers who come in and bring you through those labs to help you go through the problems that you might have as you go through this labs and quests. So if you have not yet registered, this is essentially what you will see, or part of what you will see in the registration page, where you actually show that you can do a total of over 30 different quests this time round for this season of Majulah GCP. Alright, so Harrison, which quests are you interested in? There's like a huge amount over here. You can see like some infrastructure related, like with Terraform, which actually I'm really excited about. I think there's also some that's related to BigQuery, data, ML that I think you also mentioned that could be interesting.
Not too sure whether if you are like experiencing Google Cloud Platform, there is this product called BigQuery, which is like, when it comes to data, like this one of the products that's like quite popular. Mainly because when if you ever go to YouTube, like if you try to search on BigQuery on the product itself, like they will claim about its performance. The performance is really, really great. Like you can perform a query on terabytes of data in seconds. So like if you are interested to learn this kind of technology or the platform, I think there is one course there. I think here. You see the cursor here, build and optimize data warehouse with BigQuery. So there's one potential lab or quest that you might want to take a look at. For those data guys.
So some of you might be thinking at this point of time, for Majulah GCP, this looks like a lot of work to do. Like over 30 quests. Do I need to actually finish all 30 quests to get something? And what exactly am I getting out of it? So, swags. I think all of us like swags. And as you go through this learning experience in Majulah GCP, the bonus here is you get swags. So the number of quests is related to the different tier of sweats you'll get. And as I mentioned, there's over 30 different quests that you can do. You must do it within the duration of this campaign, within this month itself. So if you complete the requisite amount of quests, as you see over here in this image, you should be able to get the tier that you want. Okay, so you can see over here some really exciting stuff, right? I mean, of course, there's the standard stuff like t-shirts, water bottles, sling bag, but there's actually a very exciting addition this time as well. Laptop stand, which actually I think is pretty cool to add this time around.
Yeah, that's a new one. In previous seasons of Majulah GCP, like laptop stand has never appeared, if I'm not wrong. I think sling bag also is kind of new addition as well. So I guess like it's a bit more plus.
Yeah, so just to also note these two links at the bottom of the page, Horizon earlier on mentioned that we do have a community who is there to try and help you answer questions if you are stuck on certain labs, especially those challenge labs that you might see later on as you do the quest, where you actually don't see the instructions, but it's more like a test to get you to understand if you know like what the how to complete the lab by yourself. So if you do need some help, definitely do check out this Slack link and join our Slack group to get some help. And also, make sure that you register. Later on, we'll show this link again. Just if you have not yet registered for this event, you do need to register for it so you can get some code to be able to use quick labs for doing the labs later. Okay? Okay. So I think actually we might be running a bit low on time, so I think we'll skip this part. But if you can take this links over here later. Probably we'll find a way to share with you all again. But this essentially, you can take a very quick photo of this QR code. Essentially, this video itself will show you how to get started in terms of getting registered and then qualifying for the 1 month subscription to go through all the labs for this Majulah GCP season. Okay, so I'm just going to wait for around 10-15 seconds for you all to take a very quick photo or take this QR code. Freeze here for 15 seconds. Yes.
I have several questions. I don't know whether this is the appropriate order. So, I've completed some of the labs in some of the quests prior to this event. No need to come up. I've completed some of the labs in some of the quests prior to this event. Doesn't matter why, right? So yesterday night, I completed the last lab in one quest. So is that counted?
So to answer this question, if it's within the period, I think this is starting from 1st April, yes, you'll be considered as part of this Majulah GCP 1 month long campaign. But for those that's completed before, no, it's not counted. Yeah. So later on, we'll actually show a link, a progress tracker that you can actually see what are the other labs you can do to qualify. So you don't have to finish all 30. As long as you finish 14 out of that 30, those not available. Okay, yeah. Yeah, so just one more. Again, I'm going to leave this up for around 10-15 seconds. This is more for instructions on how to claim the swag later on at the end of this, once we finish all the 6 quests or 14 quests. So I'm going to move on to the next slide. Okay, so yeah, this one's the one I was mentioning just now. This is something actually we built within the community. If you're interested, you can actually visit this link. And essentially you can see this GIF over here. You can put in the public link and then once you press enter, you actually see what are the labs that you can take to qualify for this season of Majulah GCP. So like as mentioned, as asked earlier on, if you already completed, let's say 5 quests, that is under this list of 30 quests right before this campaign, they will actually take it out and not show it in this list. So you will have another 25 that you can do. So that's the reason why I think from Google side when they manage this campaign, they want to release as many quests as possible so that if you have already completed some of those from the previous campaigns, at least there's new ones you can try. In fact, from this time around, at least half are new quests, while some of those are from previous seasons as well, like for those who haven't tried it yet. Okay, so but yeah, if you do have questions on the availability of some of these quests, or you have suggestions, I think definitely we have the organizers here today. You can talk to us, let us know if you have any feedback. Okay. Alright, so yeah, just to mention very quickly for later on the breakout sessions, we're going to have 2 tracks, the infra track as well as the data track. Infra track will be for this room. Data track will have volunteers to show you the other room. It's actually, if you go out of this room, you turn to the right, there will be a this tutorial room all the way at the end. That's where we'll be doing the second track. Yeah. So before we move to the next part, which is actually showing you how to get registered for Majulah GCP, I'd like to take a very quick group photo first with all of you. So if it's possible to move to the middle a little bit, and also for volunteers, please come in. Let's take a group photo.
You sit in front. Maybe the organizers, you're going to sit in front.
Where should I?
Maybe I'll take the photo.
I think for the people on this side, would it be possible if I can join it? So it's easier, then we just take this 2 columns down. Thank you.
Last one, 1, 2. All right.
Thank you so much. We'll put it into the Slack channel. Thanks, Ryan.
Thanks, Harrison.
Thanks for joining us in this photo. Definitely, we will post this online. If you all did the registration just now, make sure if you haven't put in the handler, let's say your Twitter handle or whatever, make sure you put it in. We'll try and tag all of you if we can. Yep. So this one, okay. The next part over here, actually, we want to already break you out into the breakout rooms. But we just want to make sure that you have already done all the prerequisite steps before you go to those rooms, because by the point of time, I think some of this, at least the earlier parts of this steps, right, up to 2B should be done already. Alright, so just to explain very quickly what this is. Okay, firstly, Wi-Fi at the top right hand side of the screen. Definitely do connect. You do need an internet connection to do this labs. Okay, and for point number 1, okay, this is just making sure if you have not yet registered for Majulah GCP, okay, not for today's like this on this live event, or for the actual campaign. If you have not yet registered, please do visit that link. It will be good if you can do it now. Register for that. You should be able to get an email telling you, the following steps of what to do. Okay. And then if you have already registered but you have not yet received the email, do visit this link at either 2A or 2B, depending on which track you are going. Okay, both of them are actually the same. It's just directing to the different lab that you want to do. Okay, so this link also contains the code, right, that's required to get you registered to this campaign. Okay, so you just need to make sure you get to this link and then immediately just sign in from there. And later on, during the breakout sessions, as you do the lab, you will be able to qualify and get that month-long subscription to run through the remaining quests for this month. Okay, so later on, this last part, complete at least one lab, right? This essentially just means the study jam later on, the one single lab that we'll be doing. Yeah, so I think this is the ending portion of this, I'll say, briefing part. So once you're done, for those people who are going to the data track, like I mentioned just now, once you exit this room, you go to the right, the data track, there's this tutorial room all the way at the end. Okay, so there'll be a signboard or some signage outside indicating that room as well. Okay, so I'll say let's start around at 10:30, so around, I'll say 5 minutes for you to set this up, and then after that, the track 1 over here will start, and I think around the same time, track 2 will start at that same time too. Yep, so thanks, I hope you enjoyed today's event.
For those of you who are going to track
Okay. All right. Okay. Okay, this looks fine. Let me know when you're good to go. Are we good to go? Okay, perfect. Hello everybody, my name is Vamsi Ramakrishnan. I'm a customer engineer with Google Cloud and I specialize in infrastructure modernization. Perfect, sorry about that. So today we're going to look about automating infrastructure through configuration and provisioning so that human error is eliminated through an infrastructure as code tool called Terraform. Just to have a check, how many of you have already used Terraform here in some shape or form? Okay, so this lab is fairly basic and is aimed to help people get started. So if you're an expert with Terraform, apologies. The reason why we kept this is to get the maximum number of people to get started on Terraform and start playing around. And so without further much ado, let me get started. Why do we need infrastructure as code, right? First thing is that there's rapid demand with regard to scaling IT infrastructure, and there's a lot of operational bottlenecks, and there are a whole lot of companies that are moving things from on-premise to the cloud, and there are new digital companies that are getting created day by day. So the cost of manual errors are becoming extremely expensive, so the ability to consistently define infrastructure and operate using infrastructure as code because of its ability to be versioned is one of the primary reasons why infrastructure as code has become extremely popular. It's not just about automating it, it's about getting a desired state configuration and getting that desired state configuration represent the current state of your infrastructure sprawl, and then versioning it so that in case something goes wrong, you have the ability to roll back just like you would roll back a piece of code which didn't work. So like I said, automation is just one of the benefits. Terraform is declarative, which means that you specify the desired state of infrastructure and Terraform does the rest of the things for you, which means that when I say specifying the desired state of infrastructure, it means you say, I need a network and the network should have a subnet, and in that subnet I want to place a bunch of VMs, and along with the VMs I want to provision a certain amount of storage, and this the ability to specify this in a structured declarative format is what infrastructure as code tools like Terraform allow you to do. The next thing is the moment you put Terraform into your Terraform declarative files or definition files into a Git repository, it automatically becomes version controlled, which means that you can track the history of changes that happened to your infrastructure. The biggest problem is application developers usually come back with a bunch of requirements to the DevOps team or the SRE team, and they say provision a bunch of infrastructure for me, and then after a certain amount of time the state of this infrastructure keeps changing. You want to be able to track and you want to be able to manage this piece of infrastructure, and therefore IAC is going to help you do this. The next thing is that you also want to be able to validate. So I think those of you who are familiar with databases, whenever you fire a query to the database generates a query plan and then executes it. Very similar to that, Terraform also has the ability to generate a plan, and the moment a plan is generated, it becomes an intermediate step for you to validate against the current state of infrastructure and then be able to apply those changes. And the next part is obviously for you to be able to scale infrastructure. Terraform becomes a very important part. So usually there's a little bit of confusion between configuration management tools and infrastructure as code tools. Configuration management tools and infrastructure as code tools both can do the same set of things, but the primary purpose of these tools are extremely different. Let's say, for example, you want to install Apache HTTPD inside of an existing VM. Your best bet would be to go for a configuration management tool. But let's say if your task was to provision that VM itself and place it inside a network, your go-to tool would be infrastructure as code. So the infrastructure as code tool landscape is pretty far and wide. Today we will be focusing on Terraform and the basics of Terraform only. There are several other infrastructure as code tools as well. One very such interesting tool is called Kubernetes Configuration Connector, where you can declare the resources as Kubernetes manifest files, and Kubernetes does the provisioning of infrastructure for you within, say, Google Cloud. This is a fairly new paradigm, and there are a lot of people who are embracing this paradigm. The next thing is there are other tools like Pulumi, which are a lot like software development kits. So for example, the problem with Terraform is you have to declare everything in HCL, which is HashiCorp's configuration language. But let's say you are a developer and you're super used to Python or JavaScript, you have the ability to use tools like Pulumi to natively work in a language that you're extremely comfortable with, rather than being bounded by the limitations of HCL. So it's like saying, do you have the ability to express yourself better in your native language, or do you have to learn a new language to really express your feelings and thoughts, right? That's basically the difference between using a tool like Pulumi versus using a tool like Terraform. Having said that, we will skip through a bunch of slides in the interest of time. So Terraform has this concept called as providers. Terraform is called multi-cloud because there are separate providers for each of these clouds. The point is that when people say multi-cloud, people tend to think that I can use the same piece of Terraform code between Google Cloud and Azure and AWS. That's not true. You change the provider, the underlying code also completely changes. The modules inside these providers are different, but it's just that because you've written code in HashiCorp configuration language already, the ability to move these definitions from one cloud to another becomes a lot more simpler because of your familiarity with the language. You don't need to learn a new way of provisioning things and so on. You can still go with initialize, plan, and apply as 3 separate stages with your infrastructure provisioning pipeline. So let's go with the basics, right? First thing is that you've got to install Terraform. But today in the Quick Labs console that we'll be opening, we will primarily be using Cloud Shell to interact with Terraform and the infrastructure. So Terraform is pre-installed, and then we define a file called main.tf, which is where you define individual modules or components inside, and you essentially provision the infrastructure. Terraform init is basically initializing Terraform. When I say initializing Terraform, what it does is it essentially creates what you call as a state file. This state can be hosted locally from where you're running, or it can be hosted in a remote setup along with the cloud provider. For example, an object storage bucket could be a state store. Why is state very important? Because in this case, let's assume that you started provisioning infrastructure, you said provision 1,000 VMs, provision 500 volumes, create the network, and for some reason your client loses connectivity to the Terraform runner that's probably hosted onto the cloud. What happens when you run Terraform the next time? Terraform has to pick up from where it left. So Terraform creates what you call as a plan and a state, and it always refers back to the state and the plan to decide what to do next. So let's assume you created 5 VMs, and then in the next time you change the number of VMs to 6. Terraform doesn't destroy all the 5 and recreate the 6. Instead, Terraform creates 5 and adds, Terraform doesn't touch the 5 VMs and just adds 1 more VM. This sort of ability to perceive what's the current state of the infrastructure is what makes Terraform extremely attractive and powerful. So, and that's it. Let's look at some of the common ways in which things are organized in Terraform. Usually you will see a lot of files with the extension .tf, and some people are very comfortable in using JSON as opposed to HashiCorp configuration language. Terraform gives you the ability to do that. So if you define something in .tf, it's HCL. If you define something in JSON, it's usually .tf.json. You want to make Terraform scripts as extensible as possible and as applicable as possible in multiple environments. So what you really do is you create variables and you substitute the variables in a variable file so that when the script actually runs, you just need to modify the variables and you have the ability to make the code a lot more portable, and you don't have to go and modify the entire directory structure that you created in extremely complex environments. So when I say complex, I can give you examples. So I worked with a customer. So they had about 1,000 projects to create within Google Cloud, and they had to onboard over 2,000 users, and they had to create a shared VPC and connect it to over 10 other service projects, and they wanted to create over 100,000 VMs over a period of time. They had to manage the IAM privileges, the folder structures. So the Terraform directory structure itself is super huge. It would maintaining the directory structure itself is painful. So making your code composable is super important with regard to Terraform, and you have certain hacks to make sure that you don't fall into trap of writing unmaintainable and unportable code. So having said that, we'll go for hands-on. I think I'll take a pause for a couple of seconds to see if somebody has any questions as of now. Otherwise, we can move straight into the hands-on lab. All right, I hope I wasn't too fast. I was just trying to, yes, sir. Sorry? Yes, that's correct. Ideally, we would like to do it together. I think if we finish one of the labs, and if you're new to the Cloud Skills Boost, the goal to keep the first module super simple and easy is for you to finish that one lab so that the entire journey unlocks for you, and you have the ability to practice these things at your pace. And I think you have a month's time, if I'm not wrong, to execute these hands-on labs. So the goal today here is to get you started and unlock the entire 1 month worth of hands-on labs for you so that you have the freedom to try things by yourself. All right. So let me know if you're on the same page. Okay, so I'm sure you'll have to sign in to Cloud Skills Boost and say start the lab. The name of the lab is GSP 750. Just make sure that you're on the same page as I am. If not, we could always, I could show you how to do this. So you would be on the automating infrastructure on Google Cloud with Terraform, and you would select the second lab in this module after enrolling in this quest. I'm going to assume that since there are a large number of people and in the interest of time, I'm going to slowly move forward. All right. So the first step is for you to say start the lab. It's going to kick off a CAPTCHA, and you're going to prove that you're a human, and you're going to get started. And once you're ready, you click on Open Console, and it'll ask you to sign in and accept a bunch of terms and conditions, and then you will be mostly seeing this page. And that's I would say step one. The first thing is that in this particular lab, right, what we're going to do is that we're going to create a virtual machine. We're going to create a security group. We're going to create a network interface, and we're going to do this in a certain project so that we understand that what's the basic provisioning workflow in Terraform look and feel like. So the first thing is that we go ahead and click on Activate Cloud Shell. So once you click on Activate Cloud Shell, you will again be asked to say continue, and then Cloud Shell terminal will open up. You'll see a button for full screen. So please go ahead and click that so that you have a full view of the code that you're typing in. For some of you, it might take a little bit longer to provision your Cloud Shell machine, but usually it will not take more than 15 to 30 seconds. All right, so the objective is, like I said, it's going to be, we're going to build infrastructure, we're going to make a bunch of changes to the infrastructure, and we're going to create a bunch of resource dependencies, which is slightly more advanced, and then we're going to again create, recreate the infrastructure. So you'll have a couple of cycles where you configure, create, and recreate infrastructure. So once, I'm just going to go through, browse through the parts that I'd already explained to you. And we just activated Cloud Shell, and we should be ready, with this. A quick thumbs up if everybody's on the same page as I am in the audience. All right. I'll just wait for another, say, 30 seconds before the rest of us also come to the same level of progress. And for all of you who've already used Terraform in some capacity, extremely sorry. This is slightly basic. It might be redoing a couple of things for you. However, after this session, I'm around. If you have any advanced questions, I'm happy to answer them. I'm happy to lead you to the right kind of resources if in case you need help with slightly more advanced topics. Okay, so let's go for it. The first thing is what we want to do is to make sure that we understand if our authentication mechanisms are okay. And towards that, the first step is to copy and paste gcloud auth list. It's a command for you to see if the right kind of account is active. And what you need to do is just double check if the name of the username, which is student04, some string, is what is active, right? And the next step is we want to make sure that our default project is set appropriately so that when you run Terraform, you provision these resources in that particular project. For all those of you who don't understand what a project is, think of it as a logical container to organize all of your resources. So a project becomes the, I would say, point of least resolution where you can enforce IAM policies, where you can enforce billing quotas, where you can enforce resource quotas. It's I would say the basic unit of administration within Google Cloud. So let's go ahead and list the projects and see which project are we configured to use. So the project is Quick Labs GCP some string. After that, just to make sure you're in the right project, just double check if the GCP project ID mentioned in the other tab is the same as what Cloud Shell outputs.
Sorry, I have a question.
Yes.
How to get the credit?
How to?
Get the credit.
So if you've done the sign up through the referral link that was there, I think, did you register for Majulah? And usually when you do that, you should not be, you get a certain amount of credits, or you will have a sign-in code. So the referral code usually works. I'm sorry. Yeah. So one of the participants in the auditorium wanted to know how to get the credits to actually kickstart the lab. For those of you who've registered on Majulah and use the referral link or code to click on to open the Cloud Skills Boost page, this should have happened automatically. In case you did not, please go ahead and register for it. In the interest of time, we will slowly move forward. All right, so as step one, we are going to create a file called main.tf. So what I'm doing is just say touch main.tf and enter. This just creates an empty file for you. And then the next step is to go and add this piece of code. I'll explain what this piece of code is. So if I say edit main.tf, it will open up the Cloud Shell editor. This is a little bit more convenient as opposed to using VI or Vim. So let's just copy this piece of code snippet in step 3 and paste it. All right, if you notice here, it speaks about a required provider. First, we're telling Terraform that we are using the Google provider for Terraform. And the next thing that we're doing is we're defining a certain version of the Google Terraform provider, because there are obviously alpha and beta channels in Terraform where some of these things may break. So usually when you go to the Terraform website, it talks about a stable version which you stick onto in your actual environment. Now, if you notice here, we are configuring which region of GCP we're using this on and which zone in GCP we're using this on. So for those of you who are not too familiar with Google Cloud, a region is comprised of multiple zones, usually 3 or 4, and we're just specifying that we want to provision infrastructure inside of this project, inside of this region, inside of a zone, inside of a region. So that's what we're doing. if you notice, the project ID is something that we'll have to configure. So what I would do is just go to the other tab, copy the project ID, and go ahead and paste it. All right, and then let's go back to the next step to understand what we are going to do. So the next, like I said, it talks about the Terraform required block. So it talks about the required provider, which we spoke about, and we're defining that Google is the required provider here, and the source is in the HashiCorp repository and in the subdirectory of Google. And like I said, once this file is defined, once you've defined your project, and once the file is saved, let's go back to the terminal and let's type Terraform -v to see which version of Terraform is installed. If you have an output to this command, Terraform is installed and things are working fine. And if you don't have this, which is very, very highly unlikely, you would have to go ahead and install Terraform. So now let's go ahead and initialize Terraform. So once you type Terraform init, what Terraform does is that it initializes a backend to hold a state of whatever file that you're creating. So if you notice that what it's saying is that there are a bunch of configuration blocks that are deprecated. So let's go ahead and okay, so the versions are deprecated, it might work, but the point is that they're asking you to switch over to the new format of Terraform. Anyway, so the next thing is that we in our Terraform file, what have we done? We've said that we have a resource called Google Compute Network, and it is of type VPC network, right? And the name of the resource is Terraform network, right? Now, if I go ahead and type a Terraform apply, what it is simply going to do is pick my project ID, which is Quick Labs, and in the region and zone central 1 and so on, just create a network by name Terraform network. So this is basically the extremely basic way of doing things. Nobody defines anything like this in the main.tf, but it's a good way to get started. So now we type Terraform apply. So now what it's saying is that there's obviously, it's complaining about me using a deprecated standard of defining things, but things are working fine here. Terraform is asking me for confirmation. I'm going to say yes. But before doing that, if you look at it, the plan gets generated and it says Terraform will do the following actions for you. It will create a Google Compute Network of type VPC network, and it has taken some default configuration files by configuration values by saying that it will create subnets. It will also delete rules on create. So there are some defaults. If you don't define these parameters explicitly, what you need to do is just go to, say for example, Terraform Google Cloud VPC network block, to just look at the documentation, and it tells you what are the mandatory parameters, what are the defaults, and what is the argument reference. So if you look at it, we just took the extremely basic setup here, but there are obviously a little bit more of advanced ways of configuring things, right? So one of the simplest things to do is if you want to create a piece of infrastructure, you simply go create a simple empty file called main.tf, define which provider you want to use, which is Google Cloud, and then go ahead and define which component inside of Google Cloud you want to provision, and go to the documentation file, go check which are the parameters that you need to configure mandatorily, what are the defaults that Terraform itself takes if those parameters are left unconfigured, right? So let's go on ahead and say yes. Now it's going to obviously create a VPC network for me. Now we can always verify if the VPC networks are getting created by going to the page VPC networks, and if you look at it, there is a default network that gets created every time a new project is created, but the moment you go just scroll down, you will see that there is a Terraform network that we provisioned. So Terraform is doing the job for you, and what Terraform will now do is, after creating this network, it would go and update the state file, saying that, hey, for this file called main.tf, for this definition that somebody defined for me, I've already created the network. So that the next time, what Terraform will do is quickly use the state file to refer and understand if it is necessary to re-provision this or just skip this. So if I go ahead and do a Terraform apply once again, Terraform will not re-provision this piece of infrastructure. Instead, if you look at it, Terraform has compared your real infrastructure against your configuration and found no difference, right? So it's able to understand what's the current state and decide what needs to be provisioned, right? So that's a very brief overview of this. So now we created our resource, and what you could also do is run Terraform show. This is a simple way of taking stock of what was created. It's just picking up one single part of what the provisioned output, and it quickly tells you what was the resource that actually got created during this particular run, right? And now you can go to check my progress, and you should get a tick mark, and I'll just wait for a brief, maybe 30 seconds to 1 minute to see if you're all on the same page, and I'd request you to give me a thumbs up if you've come to this state. All right, so let me know if I'm going too fast or too slow. I'll try to adjust my pacing appropriately. Sorry? Too fast? Okay, I'll go for a little bit slowly. Thank you. Thanks for the feedback. Yeah. Okay, so okay, so all right, I'm just gonna explain the question once again for the benefit of the audience on the live stream. So let's go back to the edit terraform.main.tf file. So let's go for that, and let's go full screen. I think one of the pupils here had asked for what's the purpose of having the region and the zone here. So that is the API specification that Google puts in the Google Cloud API. So what Terraform really does is Terraform sends REST calls to the underlying cloud infrastructure as a service API. So even if you use the Google Cloud CLI, which is another way of interacting with the infrastructure to provision and deprovision resources, what you do is you always set what you call as a default region, default project, and default zone for compute, right? While for your VPC network, this is not even relevant, because what you do is you create a global VPC which spans across all Google Cloud regions, but because the API specification says that I need a default zone, default region, and so on, it does that. Now the point is you can always remove this and it would still work. The only point is that Google would pick its own default region while setting it. So what would happen is that if you ignore this and you go to the compute block and provision a piece of compute, what it would do is it would take what Google has defined as its default region and not necessarily provision it in the region where you want it to be provisioned, or the zone where you want it to be provisioned. So that's the risk of not defining it. So it's just more like convention for you to do this. Does that answer your question? Thank you. All right, so we created a very, very basic step in Terraform. We created a VPC inside of a project. Now this VPC is ready to host a lot of VMs, and you can obviously attach storage to these VMs, right? Now, if you notice, in infrastructure there are inherent dependencies, right? If you don't have a project, you cannot create a VPC. If you don't have a VPC, you cannot create a VM. If you don't have a VM, You could provision storage, but nobody will write data to it. So the point is that you have these inherent dependencies within infrastructure. So therefore, when you define these things in Terraform, the same dependencies sort of trickle down to Terraform's definitions as well. So for you to provision infrastructure in a consistent shape or form, if you try to create a VM without defining a VPC, it would go onto the default VPC that gets created for every given project, right? If you don't provision a project, you will obviously have a problem and you will have a bunch of issues that Terraform reports. So let's go and add a compute instance, which is the next step, to our main.tf. So let's just copy this and come back, and if you're on the terminal, just go and type edit main.tf and you should see this screen open up. Let me zoom in a little bit further so that the font size is a little bit more readable, right? So let's go ahead and add our new resource, which is Google Compute Instance, VM instance, and the name is Terraform instance, and the machine type is F1 micro, right? This is an instance type that you would specify. And what you're also telling is use the boot disk, which the OS is what uses this image to boot up from, as Debian 9, right? And then what we're saying is you use the Google Cloud Compute Network VPC network name, which means that I'm telling them use the Terraform network to provision my VM instance and not my default VPC, right? What I'm inherently doing is telling them that. Okay, so a couple of things here. Again, go back to the same logic. Just go to Terraform and say Google Compute Instance. Sorry. Okay. Google search is better than Terraform search. All right. Okay. So if you look at it, showing a bunch of wrong results. Yeah, there it is. So if you look at these resources, what it really tells is how can I provision these instances, and there is obviously a documentation that accompanies it. So whenever you are trying to replay with this lab, just go ahead and look at the documentation, try to modify a bunch of configurations and see how Terraform responds. In the interest of time, we are not doing all of that in this lab, but I'm just trying to teach you how to fish here. So yeah. So now we just save, the document gets automatically saved, and now the next step is obviously to go and do Terraform apply. So let's do one thing slightly different here. Instead of going and applying this plan directly, let's do a Terraform plan. Okay. So what it is telling us is that I will create a compute instance, right? And I have taken a bunch of known parameters that you have defined, and I'm also going to infer certain default parameters, like I said. And there are certain things that I will know only after the resource is provisioned. What it means is that I don't know what the IP of the instance is until I actually provision it. So at the plan state, I will not be able to tell you, right? So those are some of the things that you probably understand as you start playing around with Terraform. Not all of the infrastructure's state information is available to you prior to provisioning. Some of this information is only available to you after provisioning. So I think somebody had a question. I saw someone raise a hand. Sorry about that. All right, so let's go ahead and say Terraform apply. So now it's asking me to confirm. Let's go ahead and say yes. And it's going and creating the VM instance. All right. Now, as it creates the VM instance, we can always go to the compute engine, which is the service name where VMs get created. So go to VM instances, and you should see that the compute engine just provisioned a VM instance for us, right? And that's the next step. Now, what you could do is that you could always go and make changes to the existing setup without reprovisioning it. This step is some kind of a demonstration to do that. So if I go to edit main.tf one more time and let me go to full screen, you will notice that there are no tags of any sort. Tags are usually used to identify who this instance belongs to, what's the purpose of this instance, and it also gets aggregated at a billing level, so that in case your organization or your company wants to understand at a summary level what's the monthly bill or costs look like. So that's the reason why you use tags. So what we've been asked to do is add another attribute called tags. So let's go ahead and add this attribute. So, all right, now I'm just saving this and I'll go back to my terminal and let me do a Terraform apply one more time. So now what it does is that it is not going to modify the instance in any shape or form. All it's going to do is add this additional tag called web and dev to the existing instance without provisioning it or modifying it. So let's go ahead and say yes. All right, so there's one instance that got changed, but nothing got destroyed. Now, we can go ahead and check our progress. And give me a thumbs up if you're all on the same page as I am. I'll wait for maybe a minute or so. If somebody has any trouble or questions, please feel free to address them here. I'll also readdress the same question to the live stream audience, and we can move to the next step after. Okay. Can we move on to the next step? Everybody who's done it, please give me a thumbs up. Okay, perfect. All right, we're going to talk about destructive changes in this section. All the way until now, we were creating resources and modifying them without yes, please. That's. Okay. So the point is that the self-link resource will have a prefix, which is the Google Cloud URL. So if you notice, the self-link will not have the full URL. It will only have a /project/ something to begin with. Is my observation right? So let me do a Terraform show. Okay, so are you looking at this? Yeah, okay, perfect. So the first thing is that the self-link is something that you would use. It's like a REST API, right? So everything in Google, okay, let me repeat the question for the live stream audience. So we provisioned a resource, Terraform gave us an output, and one of the people here had a question saying that what's the self-link and what's the purpose of the self-link, and if I click on it, it's obviously giving me a 404, or it's probably giving me an access denied error if it's opened onto a new tab. So how this works is that every resource in Google Cloud is a REST resource. So let's if you look at the model, if you look at it, so it says googleapis.com type compute, and the version of the API is v1, and inside of the projects and inside the name of the project called Quick-Labs GCP. Oops. So yeah, if you look at this, it says request is missing authentication credential. So what happens when you use Cloud Shell is that you would have done gcloud auth login or gcloud auth list or something like that, which says that I've already logged into Google Cloud Platform as user somebody, and I'm authenticating myself as this user to Google Cloud, and in the IAM policy I'm authorized to carry out a certain operation. But you open a new browser tab, you don't send that payload of authentication token into this. So if you go to the same URL, go to Postman and get your authorization credential, send it as a bearer token, you will see the list of properties that this particular thing lists. So think of this as you being rejected because it's just trying to authenticate itself as an anonymized user without the bearer token that gets generated during the time of auth. Did that answer your question? All right, perfect. Okay. So now we're going to talk about destructive changes. So there are certain changes to infrastructure which cannot happen without destroying the resource, or say for example without having a downtime or taking a downtime. One such example is changing the OS itself. So so that's what we're going to do right now. Now if you go to the boot disk block inside of your VM instance, so that's what this is trying to do. So let's just copy this boot disk block and let's go to edit main.tf, and if you notice this boot disk block today at this point in time is Debian 9. We'll go ahead and modify this to container optimized OS, which is an OS developed by Google to run containers. Typically, if you've had the experience of working with Google Kubernetes engine, all of the nodes in the node pool typically use the same container optimized OS. All right, so that's now let's go ahead and plan before applying it because the changes are destructive. Now if you notice, it says one to add and one to destroy. What it's really saying is that I have to destroy the existing resource. I cannot modify it. Because I destroyed it, I also have to recreate a new instance in its place because I modified the boot disk property. But let's assume that you created a new additional data volume. This change would have not been destructive. Because you swap the boot disk, it is destructive. Now, there are a few other changes which are deemed to be destructive changes, right? So for example, if you change the auto-scaling minimum number of instances, say from 5 to 2, it would have to destroy 3 instances because the minimum required is only 2. So there are destructive changes in this. So let's go ahead and do a Terraform apply. And our resource will get destroyed and a new instance would get recreated. Now, let's go ahead and destroy all of the infrastructure that we created. And when I say Terraform destroy, what it does is that it basically says that I want to erase all of my existing information about the state file by referring to it. So if apply is construction, destroy is destruction. So it's the exact reverse of how you traced your path forward, you're going to trace your path backward. So the state file would say that I have one VPC, one VM inside of that VPC. So when I apply destroy, it would go and destroy the VM first and then go destroy the VPC next, right? So the forward dependencies and reverse dependencies are followed in the exact same direction. So that's why Terraform is a directional tool, right? You can consider it like that. So let's first go and see if, oh, sorry, I didn't accept. So it didn't execute. Sorry about that. So once it's done with this step, it will, try to create a new instance. It's going to take some time to destroy the existing instance because Terraform tries to, send an API signal to destroy it. And what the Google API does is try to do graceful shutdown of the VM. And once the VM is gracefully shut down, then the instance gets terminated. So that's usually the destroy process is a little bit longer than the creation process. So yeah. Okay, so now, yes, please.
At this point, when we have provisioned via Terraform, suppose we have taken a snapshot, and that is done with a portal console, and now we destroy this. Will the snapshot also get destroyed?
No. So like I said, the state file is like the holy grail, right? It maintains what Terraform knows about. There could be so many other infrastructure pieces that exist within the same project, within the same VPC and so on. Terraform has no knowledge of anything outside of the state file. So if you go to, if you choose object storage as your state file and you go to the object storage file and modify it, Terraform can lose track of infrastructure. If you corrupt the state file, Terraform will try to rebuild the state, but the point is that you'll have to do a slightly different process to rebuild the state. It's a slightly advanced topic. What you do is you try to specify a scope and you try to import into Terraform. What it does is that for the existing infrastructure state, it generates a new state file, which means that let's say I created 5 VMs on Terraform and then I created 10 VMs on the console. Now I want to bring this 10 VMs also under the purview of Terraform to manage, so that this also becomes part of infrastructure as code. I'll have to do a Terraform import. So what Terraform will do is import the additional information and then merge it with this state file to generate a new state and say that okay, back then it was 5, now it's 15, right? So that's the way you have to sort of bring it into the purview of Terraform. Now let's go ahead and apply Terraform destroy. So for the benefit of the people in the live stream, I got a question which was about what happens if I take a snapshot of the disk that was attached to the VM, or say make some changes to the VM, create a new image. Does Terraform destroy that as well? It does not, because Terraform has no knowledge of what has happened outside of the state file. All right, so let's go ahead and check my progress here. We have only 8 minutes onto the lab. I think I took too long. Let's rush through the lab as quickly as possible. Okay, it's still destroying. Yes, yes.
So in the VM that was created, let's say you were to add another tag using the UI and you run Terraform destroy, does it get destroyed?
Yes. That's because when the state resolution is done, so there are two kinds of ways in which Terraform tries to understand the state, right? So one thing it does is that when I destroy the infrastructure, Terraform uses the state file to refer to what has happened to the infrastructure. If I added a new tag, my state file does not get affected, and the state file's current state is used to destroy the infrastructure. So the additional metadata information that you entered is of no use, because I destroyed the container, which is the VM which holds this information also. So I went one level above the hierarchy and destroyed it. Yeah, it's a little bit quirky. There are lots of these conditions that become more and more complex with this, which is precisely why what people do is that when they say there is a Terraform project, you completely ban console access, CLI access, and other forms of access, and your state file and TF file on GitHub becomes your frame of reference. And even if by mistake somebody made some changes, you try your level best to import that state into Terraform outside of this and try to merge it. So that's the way in which people handle things. All right, let's check our progress, and please give me a thumbs up if we're all on the same page. Now, what it's asking us to do is to assign a static address, IP address. So let's go ahead and create the static IP. And then what it is asking us to do is to create a Terraform plan. So type Terraform plan. Okay, what it is trying to do is that it's because I destroyed everything in the Terraform destroy command, it is creating everything from scratch. So the compute VM instance is there, and also the static IP is there, and then the VPC network is there, and so on, right? So now let's go ahead and do a Terraform apply. Is that what it says? let's go for yes. So if you notice, it's creating a static IP first, and you will notice that that static IP is what will sort of get applied on the particular VM. So if you update the access configuration in the VPC to take the static IP address, so you go to the, after this infrastructure gets provisioned, what you can do is you can again go edit main.tf, and what we did is we also additionally provisioned a static IP, and the static IP now is not assigned to the VM that got provisioned, right, or the VPC where it is. So now we can go and modify. So if you notice in this network interface section of the VM, what we would do is we would go and paste this network interface section. Let's just delete the network interface section from this and paste this. So what you will notice is that here the VM static IP address of what got created in the previous step is what would get assigned to the network interface of the VM. So if I do an open terminal once again, try to do a Terraform apply. So you would notice that it would just make one change. This is not a destructive change. And if I type yes, it would go and create it. And I think we can, then what it asks us to do is just do a out Terraform IP, which is output the static IP right now, and then it says apply just that part of the setup. So just say apply static IP. What this would do is that there's no changes, so it's not making anything. We can go and say check my progress. Thumbs up if you're on the same page. So in the lab, what they're asking us to do is just provision it like before, and then provision a static IP and then apply that. What we did instead is directly went and made that static IP as a part of our main.tf and applied it in one single go, right? So thumbs up if you're on finish this part. All right, I'm just going to wait for a couple of minutes. There's only a couple of minutes, sorry. All right. Okay, so since we have very limited time, I'm gonna quickly explain this part. So if you look at the main.tf, what it's asking us to do is add another resource called GCS bucket, which means that if I go and edit the main.tf file now, I can go, say, for example, right below the resource, and let me give a bucket name saying that give your own name behind or something, because object storage buckets are global, so we can't have the same names. So I've just created a bucket. Now in the next step, what they're asking us to do is use this additional thing called as depends on. So it's saying create another instance that depends on this. So let's go ahead and add that to our file. Copy paste it. So if you notice the file, you will notice that it depends on the example bucket, which is here. So if you notice, the resource name is Google Cloud Storage example bucket, right? And there is a simple thing called as depends on, right? And this depends on means that I will never provision this resource without that. what is the advantage of doing something like this, right? Let's say you provision a database first, then you want to provision the VM. Both of them are VMs. There is no implicit dependency, but this is an explicit dependency. You don't want to initialize your application without the database getting initialized. So you can help stitch some of these dependencies more explicitly rather than just depending on the implicit dependencies in the infrastructure, right? Which means that VM cannot be created without the network, or I would say storage volume cannot be attached to the VM without the VM being created, and so on. So yeah, now let's go ahead and open the terminal and say Terraform apply. Now I say yes. And I think that's the end of the lab. I mean, while we should have probably accelerated this a little bit further, there's a few more sections in this lab. We can obviously restart the lab or try this. The instances are still functional. You didn't close your cloud console, so we can go and do main.tf. You'll not be able to check your progress, but we can just finish this off really quick. Now, we've created this infrastructure, we've defined dependencies amongst infrastructure and things like that. Now, what it also allows you to do is create custom operating systems. So let's assume that you have a certain boot volume with a certain OS and a certain patch version. You want to pack and build this image and then use this image to provision the VM rather than using the default Google Cloud images that are provided. Terraform provides a way for you to do this, and also a tooling kit to help you do this. It's called Packer. If you're interested, you can look at it. Using Packer itself is a huge topic in itself. So yeah. Now, the other interesting thing that I would like you to look at is that you can write what you call as provisioners. So in this provisioner, what you could do is create local exec commands. So if you notice that in your provisioner, after the VM instance gets provisioned, you will run some of these commands inside the VM instance, right, to output a bunch of things for you. So there are so many provisioners within Terraform that can help you establish a bunch of tasks. So while it is not a replacement for a configuration management tool, right? Say for example, you want to install a certain version of Java and then copy your application artifacts, modify a little bit on your pom.xml file or something like that. Don't do so much of things in Terraform. It's primarily meant to be an infrastructure provisioning tool. While it does have the capability, it's not the best practice to use Terraform like that. You use tools like Ansible, which is another configuration management tool to handle things for you. There are certain people who like to write what you call as init scripts, so that they will attach an sh file called init.sh, so that when the instance boots up for the first time, this init script will run and install whatever packages they want. So there are many ways of doing these things. So this is just one of those ways. So we are almost on time. I'm going to take a pause. I don't know if there's somebody manning the live stream and if we have questions on the live stream. All right, cool. No problem. So I will take a pause here and answer any other questions that you have. And that's the end of the session. Hi.
Do you want to do any Q&A with them?
Yeah. I said yeah. I'm
So yeah, before we continue, I'd like to thank Wansi for
thanks.
Going through with this step for today. So can you guys help me give him a round of applause?
Oh, thank you. Thank you so much.
So yeah, I think he'll be here if you need, if you want to ask him directly any questions pertaining to the dev, or I guess if you have other questions related to infrastructure. But until, I think let's take a few minutes of break as well. I think for you all, you have been here for an hour or more. If you need to visit the washroom, it's just right outside. Then if not, try and prepare around at, I would say 11:45 lah, where that's when we will do our closing. So yeah, see you all later.
Yeah, I'm around until what time is the event?
It's only 12.
Okay, so I'll be around at 12, and if you have any questions, you can just walk up to me, or I could walk up to you. Anything works. Thanks.
Hi everyone. So thanks for joining us in our event today. I hope you guys had fun learning, going through these last few hours, doing the 2 different quick labs with us in the 2 different tracks. So once again, thanks for joining us in one of our first physical events, not just for our group, but also within Singapore itself. I think this is really a very huge milestone achievement for us, moving the days ahead. Just one reminder over here. If you have not yet registered, please make sure you go to that Majulah GCP link. This first one over here. The second one, I think just now some people feedback that they weren't able to join the Slack group. So we created a bit.ly link, right? This one should contain a token that allows you to be able to create this account directly on our Slack workspace. Okay, so just make sure you take this down if you want to use it for asking the community questions later on if you're stuck at some of those labs or quests. So I'm going to leave this up for 10 seconds for you all. Take it down. Okay, I think someone mentioned there might be some problem with this thing, though it was working just now. I think we'll check it out later and share in our Facebook page or something if it doesn't work for you.
Can you share the Facebook?
So I know it's been a very long first few hours of this morning. Thanks for joining us for this physical event today. Of course, the one thing that you guys are waiting for, swags. Yes, for today we are giving swags as well. But because this is, we are in this pandemic situation, we also don't want to create a scene where we are all crowding around the counter. So later at the registration counter, we will be giving out the swags over there. But I need all of your cooperation. Let's go through in an orderly manner. So make sure you form a queue over there. But we'll do it by rows. So this is where I think just now some of you heard about the pro tip. Let's start off with the first few rows. So let's go with the first few rows first. Please form our orderly queue and get your swags. So for the rest, overall, there is enough swags to go around. Okay.